Historically, probably the first architectural style that became pervasive was called the master control. That is, you'd write a top-level routine that was responsible for organizing the use of the lower-level routines. Some of the other ones listed on this particular listed here are more recent. Message bus is an analogy with the hardware bus that organizes computations on a chip. Message bus often means asynchronous message passing over some common data channel. With your smartphone or other mobile devices, there are a set of constraints that you have to deal with that you wouldn't have to deal with in other kinds of applications. So architectural style in support of mobile code, where there might be remote evaluation and you have agents at various places on a network, is an example of a mobile code architectural style. The term object-oriented architectural style is a little bit different than object-oriented programming or object-oriented programming language. With the object-oriented architectural style, we still have objects, but each of those objects have an independent existence. That is, they're running all the time, they have their own thread of control, and they're sending messages to each other, asynchronous messages. This allows them to cooperatively address the problem being solved. Peer-to-peer networks you may have heard of. Here there are equal parties sharing responsibility for providing whatever services. Plug-in architecture, if you are familiar with some interactive development environments like Eclipse, you know that there's a whole registry of available additional functionality that you can plug into Eclipse, and the mechanism for doing that is a very powerful way of adding extensibility to systems. Pipe and filter you've seen before with the quick exercise. One you haven't seen probably is process control. Think here nuclear reactor. Think here your speed control on your car. The situation is you have some ongoing hardware process and you'd like a corresponding software application to control that process. If the process is going too fast, you want to slow it down. If it's going too slow, you want to speed it up. This is called process control, and its key element is some kind of feedback loop. From the artificial intelligence world, there's production systems. These are essentially a collection of rules and the conditions under which the rules fire. It enables the modeling of systems where we don't have a clear idea of what the control flow needed to implement the system. A very popular one these days is REST. REST stands for Representational State Transfer, and you can think here it's those internet applications that are using HTTP that often have a client-server type relationship that are stateless. That is, each of the user requests are handled independently and with some potentially some caching going on to improve performance. Service-Oriented Architecture, or SOA, is where we have carved up the functionality of the system into separate services. That is, from the user's point of view, a service is a self-contained unit of functionality. And that means that we have to imagine the architecture of the system as being able to support a set of services. These are typically done in support of enterprise-type applications and often with an internet connectivity between the user requests through some browser and the ultimate service being provided by some server. Shared nothing is a term for distributed database with no sharing across the nodes. I don't personally have a lot of experience with that one. State transition systems, on the other hand, are very common, particularly if you have a situation where the system is driven by events, asynchronous events, and it has to react to those events. The typical example is if you've got a GUI and the user is providing the events. But it could also be some kind of real-time system where the events are coming from the outside world. Shared memory we saw from the quick exercise. And finally, we have table-driven interpreter. For certain kinds of applications where the requests take the form of simple expressions in some kind of language, we can deal with those requests by having an interpreter. The interpreter is essentially taking the request, parsing it, and then invoking whatever procedure is required to deal with that specific request.